Good day, students. In a previous video, we talked about chemical kinetics and also rate of a reaction. We were able to establish that the rate of a reaction is a change in conc of a reactant or product per unit time. In case you've not seen the video, I recommend you go back to the previous videos and check it out. Today, we'll be talking about rate expression. But just to recall, we know that rate of a reaction R is change in concentration, change in conc of reactant or product over a change in time. Change in time. Okay, let's assume that we have an hypothetical reaction like this: A to give B. In this sense, A is the reactant and B is the product. So what will be the rate of reaction of A and what will be the rate of the reaction of B? Now, in the previous video, I explained that as this reaction proceeds, the conc of A reduces while the conc of B increases. Since the conc of A decreases, we can write the rate of disappearance of A. So the rate at which A is disappearing will be equals to R. Let's just write it as rate of A equals to change in conc of A. Now this square braces means concentration over change in time. This will be the rate at which A is disappearing, okay? And RB, let's say RB equals rate at which B is being formed in this reaction, will be change in conc of B over change in time. But don't forget, the conc of A is decreasing as the conc of B is increasing. So therefore, how can we represent this? We use, in my previous video, I explained that we use a negative sign. A negative sign. So this negative sign is telling us that the conc of A is decreasing while the conc of B is increasing. And as I explained in the last video, I said that the rate of A at a particular point in time, the rate at which A is disappearing, rate of A will be equals to the rate at which B is being formed, rate of B. So therefore, I can say that RA is equal to RB. Also, the rate of A is equals to minus change in conc of A over change in T. And this is going to be equals to the rate of B is also what? Change in conc of B over change in T. We call this the rate expression. Okay, let's take a look at this diagram below. Now, what does this diagram tell us? This is just a graph to explain what I explained up there. Okay, let's assume that this blue slope, let me use a different color, is the reactant A. Okay, and this, what do you call this color? Whatever color it is reactant B. Just like I said, A to give B. Okay, you can see that this on the vertical axis we have concentration. This is a graph of concentration over time, which will give us what? Rate. Are you getting that? So you can see that the conc of A is reducing. It is reducing, right, until it gets to 0, and the conc of B, which is the product, is increasing exponentially. Okay, now you can see that at a particular point around here, the conc of A was equal to the conc of B. Let's take, for example, we have a different reaction. We have something like, let's say, A plus B to give C plus D. It's very, very simple. It's same as the previous ones. The reactants here we have are A and B respectively. Okay, and we know that as this reaction moves to completion, the conc of A will reduce. The conc of B also being the reactant will also reduce as the conc of C and D increases. So what will be the rate of A, the rate of disappearance of A will be minus change in conc of A over change in T. The rate of disappearance of B will be minus change in conc of B over change in T. The rate of appearance or formation of C will be change in conc of C over change in T, and the rate of formation of D will be change in conc of D over change in T. I believe you know why there's a minus sign in A and B and there's no minus sign in C and D. It's simply because the conc of A and B will reduce with time as the conc of C and D increases. So from what I just explained up there, we can say that the rate of A will be equals to the rate of B, also equals to the rate of C, and also equals to the rate of D. This simply means that the rate at which A is disappearing is equals to the rate at which B is disappearing, equals to the rate at which C is being formed, and also equals to the rate at which D is being formed. So what will now be the final rate expression? That will be minus change in conc of A over change in T equals to minus change in conc of B over change in T equals to change in conc of C over change in T also equals to change in conc of D over change in T. So this here is the rate expression for this reaction. In the next video, we'll be solving problems on rate expression.